Okay, so we're going to learn about some data collection and some correlation versus causation, and there's going to be a lot of talk in here. So you're going to have to pause the video. A lot more of this will be discussed in class, but we're giving you an overview in the notes, okay? So first of all, we have a survey. Data is from responses given by a sample of the population. We just want to make a general conclusion about what's going on. So you're writing that down. Write that down there, okay? And an example of this is whether the student body is happy with the prom theme, or whether the student body is happy with the tater tots that they serve in the cafeteria. We just ask everybody, okay? An observational study is the data is recorded after just observing the sample. So we want to compare reactions and draw a conclusion about responses of the population. So if we want to see if what toys people like the most, we just sit there and we watch kids play and see what toys they play with the most. We just sort of observe. Makes sense, called observational study. And experiments data are recorded after changing the sample. So this is kind of what we talked about in the last video when we solved for one variable. Look at how these are all co-linked. They're all put together. Oh my gosh. So what happens if I change and I add more water to the lemonade? What happens if I add less water or something? You can conclude what happens every time something is done. Okay, are the following situations surveys, which means we actually survey and ask people? Is it an observational study? We just stand back and observe what's going on, or is it an experiment? Okay, so we're going to circle our choice. A group of researchers observes 4-year-olds to see how long they wait before actually eating an M&M. Okay, people, if you get this wrong, you're not working very hard. Observes, that means it is an observational, I can't circle this, there we go, observational study. We're watching to see how long it takes for them to eat an M&M. Is that what they really want? We don't know. 2 sunflowers are planted. One is put in the sunlight, the other in the shade. So what's going on there? It's kind of, we are watching, but what are we doing? We're actually controlling the situation. So it is an experiment. We're going to see what happens with the amount of sunlight that a sunflower gets. Students leaving the talent show are asked to vote on which act they found the most entertaining. So if we are actually asking people and getting their response, that's a survey. Asked and answered survey. Okay, so bias. Bias is the way that a question is worded can reflect the results. So let's write that down. I don't know. We'll find out. The way that a question is asked can affect the result. Okay, now you're going to have to pause it for a second while you copy that down if you're not there. So if it's bias, you just sort of push your thoughts and the result that you want on people. Okay, so for example, so do you want a hamburger or a hot dog? No bias there. Do you want a nice, juicy, fat, plump hamburger or a hot dog that's made out of pig intestines? Okay, there's a little bias on that one. So which question in each category below would bias the results? So environmental issues, we're going to ask about environmental issues. And if I say, due to diminishing resources, should a law be made to require recycling? Am I sort of pushing you towards the result that I want? Should the government require citizens to participate in recycling efforts? Do you see how this first one, I'm pushing you, due to diminishing resources. Oh my gosh, our earth is dying. We need to recycle. Versus, yes or no, do you think we should? Okay, I give you a little bit of my opinion in it. That's called bias. Should sports fund, or sorry, let me read the question correctly. Should schools fund extracurricular sports programs? The budget of River Valley School District is short of funds. Should taxes be raised in order for the district to fund extracurricular sport programs? Yes, okay. So obviously the longer one's biased, but that's how it is on your driver's test too, guys. When you take that, the longer questions the answer. So on the first one, they just say yes or no, should they, shouldn't they? On the second one, they tell you, oh my gosh, this poor little school district is short of funds. We're not going to be able to have sports. And so I'm pushing my opinion on you. That makes it bias. Now let's try to write a biased and an unbiased survey question. I want to determine whether to serve hamburgers or pizza at a class party. So let's write a question that would likely produce biased results. Should, I'm not going to do it. You're going to pause the video and you're going to fill in A and B. Look at what they did here though. They served hamburger pizzas. Oh my gosh. Nyop, 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 nyop. Pause the video, write your responses, please. Okay, so now we're going to talk about population versus sample. And this one does get a little bit tough, but if you look, I love this. Look at this little Venn diagram she threw in there. Population, if you look at it, population is the big picture. Sample is the little specific group inside a larger group. So we're going to call population a large group of people. Okay, it's a large group of people, and usually it's represented by a sample. So we're going to put that in there. Usually represented by a sample. Okay, because what that means is if I want to get the opinion of all high school sophomores, am I really going to be able to ask every single high school sophomore in the entire world? No. So that's the population, though, is all high school sophomores. The sample is, I'm going to just ask the 25 that are in my class. Okay, that's not a very good results because there's a lot more sophomores, but they're represented by a sample because I can't usually get the entire population together. What is a sample? It's a small portion of a larger group. Okay, just like we said, the entire population is all high school sophomores. The sample is those in Mrs. Evans' class. Okay, pause to write that down. What is the population? What is the sample? And what is the type of data? Remember, type of data are these three: survey, observational study, experiment. In a recent survey, 3,002 adults in the U.S. were asked if they read the news on the internet at least once a week. 600 of the adults said yes. So what is the population? The population is the adults in the U.S. That's the big group, right? We have a bazillion adults in the U.S. Okay, don't quote me on that. I'm pretty sure bazillion is not the correct answer. What's the sample, though? Did we ask every single adult in the U.S.? No. We asked the 3,002 adults. That's all we could get to with our what? Survey, observational study, or experiment. Which one did we do? We took a recent survey. We actually asked them. We just didn't observe. We didn't go into everybody's house. Oh my gosh, that'd be creepy. We put little cameras in everybody's house to see if they were watching and reading the news on the internet. No, we just surveyed. We sent out a little paper and they sent it back. Probably on the internet. Okay. A local charity is interested in finding out whether people are likely to give money to charity. They distribute 1,000 questionnaires to people living in their neighborhood. So what is the actual population? It's not all people. It's actually the people in the neighborhood. Now, I don't know where you guys live, but I don't know if I have 1,000 people in my neighborhood. I'm pretty sure I don't. My neighborhood's not that big. So what's the actual sample? What's the smaller group that we did? We just did the 1,000 people who received the survey, right? So it's just those 1,000 people who got the survey. So we're going to put got survey because received, we have to remember, is it I before E except after C? And when it says A, is it neighboring way? Oh my gosh, so confusing. So we don't want to do that. So was it a survey, an observational study, or experiment? Did they control the situation with an experiment? Did they say sunlight versus shade? No. Did they just watch the people? Nope. They actually sent out a survey. They distributed a survey and got results and collected them. All right. So the next thing we have are the type of samples that we get. So what we have is, we can't ask everybody. Remember, we only can ask our little samples, not our whole population. So a non-random is a sampling method where elements of the population have no chance of selection. So it's where we are picky, right? So it's a method, how do we want to write this? Some elements, because it's not always people, right? Some elements of the population have no chance of selection. It's non-random. We are definitely picking on these people only. Random sampling is some elements, not some elements, sorry, I would pause and redo that, but I'm not really very good at that, as we know. So a sample is chosen without any preference. So nope, a sample, how do we want to write this? A sample is chosen, let's just write what I said. A sample is chosen without, oh my gosh, my writing's terrible this morning, preference. Okay, it represents the entire population. Okay, so random is just, we just send it randy, willy-nilly out to everybody. Non-random is we kind of pick who we want to have. Then within the random, there's 3 types of random, because we can't just be willy-nilly. That's not really a very good controlled experiment. So a simple random sample, samples equally likely to choose any other sample from the population. So we just like draw names from a hat. Everybody has the same opportunity. So let's put all have an equal opportunity to be chosen. And then we're just going to put a little example. We're going to put draw names from a hat, because we understand that, right? Think about when your teacher calls on you in class. That's random sampling. If she just pulls, a lot of people put names on popsicle sticks. She just pulls her popsicle stick out of the hat. That's random. If it's non-random, she's just going to only choose from people in row 1 and 2 or something like that. Okay, a stratified random sample. First of all, we divide the population into similar non-overlapping groups, and then from each group, we select. So that's a lot of writing. Ready? So first, oops, there we go. Population, can we just put pop, is divided into similar non-overlapping. Do you know what that means? That means nobody can be in both groups. You're only in one group or the other. And second, a random sample. You're going to have to do some pausing here, it's probably, is chosen from each group. Okay, so an example here is we can survey citizens of various groups based on their percent of the population. So stratified is, first I'm going to divide you into people in Indiana that are in Tippecanoe County and people that are in White County. And then I'm going to choose people from Tippecanoe County and people from White County. But it pretty much represents the population, okay? And then a systematic random sampling. This is a sample in which the items in the sample are selected according to a specified time or interval. So the elements, we're going to stick with that word that we had up there. Didn't we have an element earlier? Yeah, element. Elements are chosen according to specific time or intervals. Okay, for example, I'm going to choose every 5th person that walks out that door to ask them a question. So I don't care what the opinions are of 1, 2, 3, and 4. Boom, you're number 5. I want to know what your opinion is. 6, 7, 8, 9. Boom, number 10. I want to know your opinion. Or I'm going to, like we're running, you see this, like you buy something and it says your item was inspected by number 27, okay? They don't inspect every single thing that goes down the assembly line. They expect every 50th one or something like that, okay? All right, this is really confusing, but it kind of makes sense if you think about it. All right, look at him. That is the cutest little giraffe. We shall call him Ralph. I haven't named animals in a long time, but I like Ralph. Ralph the giraffe. Which type of random sample was used? Now it says it's random, so that means my choice is either simple, stratified, or systematic. Animals in a zoo are divided by continents. Then 2 animals were selected at random from each group to have their blood tested. So we first divided, then we selected. Divide and select is stratified. Remember, stratified is divide and select. Random is simple, is willy-nilly. And systematic is intervals. Okay? I'm just going to keep saying that so you remember them. Stratified, divide, and select. All right, here we go. Let's put it all together. Population, sample, type of random sample. Remember, population is the big thing we're talking about. Sample is the little thing we're actually doing something with, and the type of random sampling is how we collect our data. Popular restaurant. Hi, guys. The manager checks the quality of the burgers every 20 minutes, starting at a randomly selected time. Now, you might think the population is the manager. It might be the people at the restaurant. What are we doing? We are working with burgers. So the population is all the burgers cooked. All burgers cooked. What is the smaller part that we're talking about? We're talking about those burgers that we select. So it's the burgers selected. And how do we get this? Simple, willy-nilly, stratified, divide them into groups, or systematic. Do it every 3rd person, every 20 minutes, every 5th burger. Very systematically collected, okay? All right. At a bridal shower, a sticker was placed on the bottom of 3 random plates. The guests who receive the plates with the sticker win a prize. You might think the population is the guests because we always think of population as people because that's what we talk about. However, when we are talking about data collection, what are we collecting data on? Well, we're dealing with all the plates, okay? Let's say there were 30 people invited to the bridal shower. Isn't this a good time that my husband decided to mow the lawn? Wow, sorry about that. All the plates are what we're talking about. Now, which plates do we care about? We care about the 3 plates with stickers. Those are the ones that we are collecting our data from, okay? So remember, population doesn't mean people. It means the bigger thing we're talking about here. And finally, how are we collecting this? Is it willy-nilly? Are we dividing them into groups? Or are we doing it every 5th person? You might think it's systematic because there are 3 random plates. But what happened was, they planned this bridal shower, they stuck stickers on 3 plates, and then they just passed the plates out. So it was a very simple collection of data. Just who got them. Greg divides his rookie baseball cards by teams, then he randomly selects cards and records the player's RBIs. Again, you might think it's Greg. What are we doing? What are we testing? We are talking about all of his baseball cards. So the population is all, not all baseball cards, it's all Greg's baseball cards. All Greg's baseball cards. Okay, what's the sample? Which cards do we care about? We care about his rookie cards. All right. Now, how did Greg go about doing this? He has all his cards. He divided his cards into rookie cards and non-rookies. Then from the rookie cards, he randomly selected it. So it is stratified. He had a system that it was systematic. No, it was stratified. He divided them first. Stratified is every so often. Systematic is number wise. All right. Now we have two things. We have data and what happens. We have things that occur and how they happen. Does it cause one another? So we're going to talk about correlation versus causation. Correlation is just an act or an occurrence that link together. Okay, we link one thing to another. That's a correlation. That's the definition of correlation. We have something more specific, which is called a causation. And what a causation is, it is a correlation, because they're all correlations, okay? It's a correlation that indicates I wish I could write neater on this thing. That one event is the result of another event or of the other event. Okay, and this kind of makes sense to me. The word causation, one thing causes another. Okay, now what you have to remember is they're both correlations, and correlation does not imply causation. Okay, things can be correlated, they can be related, they can be linked together, but that doesn't mean one causes another. One of the things we talked about when we were doing the I-STEP practice thing is that cell phone sales go up in the months of November and December. Is November and December the cause of cell phone sales increasing? No, it's probably because of Christmas or Hanukkah or whatever holiday you're buying stuff for, but it's not because of November and December. So it doesn't cause it. They're correlated. They rise because in those months something happens, but it's not definitely a causation. One's not the direct cause of another. Okay, now on this one, researchers have noticed that the number of golf courses and the number of divorces in the United States are strongly correlated, and both have been increasing over the last several decades. Can you conclude that the increased number of golf courses is causing the number of divorces to increase? So what we want you to do is write down, is this a causation? Is the number of increased golf courses causing the number of increased divorces? Or is it a correlation? It just happens to be. You just need to give us a reason why. I'm not going to tell you the answer. This is one of the things we're going to check. This is going to be part of your homework grade, okay? Got to do this. Now, you might want to come back to this question after we go over the next couple of slides, because we're going to talk more about causation and correlation here. So we got to determine whether it is a correlation or a causation. And we want to talk about why. Explain your reasoning, including other factors that might be involved. A survey showing that sleeping with the light on was positively correlated to nearsightedness. Does sleeping with the light on cause nearsightedness? No. So this is a correlation. Okay. First of all, there are two things that I want to talk about. A survey cannot show causation, okay? That's the first thing we want to talk about. So anytime we're talking about data being collected by a survey, that's not going to show causation. A survey is just, I'm handing this out, okay, you're nearsighted, do you sleep with the light on, yes or no? That's not a controlled experiment. It's not something that shows that one thing causes the other. So if they say it's a survey, it's going to be causation. But what are other factors that are involved? Personally, I do not know what causes nearsightedness. So we could have nearsightedness is a result of, let's just say, genetic factors. I don't know. If you know more about nearsightedness, go with that. It could be part of a disease. I truly don't know, guys. I'm going to be ignorant here. All right. A controlled experiment showed a positive correlation between the number of cigarettes smoked and the probability of developing lung cancer. Does the number of cigarettes smoked help the probability of you getting lung cancer? Probability is a percent, a chance of you getting it. Yes, guys, that is true. Sorry, if you're smoking, stop. That is a causation, okay? First of all, controlled experiment, check. That tells us that we really were not just getting opinions, we were getting data. So it is a causation, and unfortunately, dangerous chemicals in cigarettes are bad. Let's just put are bad. Let's just go with that, okay? It is a controlled experiment, and that's what really helps us with the whole causation thing. It was a controlled experiment. Notice how I did not do that in 2 colors. Oh my gosh, I'm so bad at this job. All right. A random sample of students found that owning a cell phone had a negative correlation with riding the school bus. So if you have a cell phone, you don't want to ride the school bus. That's what that's saying. Does owning a cell phone cause you not to want to ride a school bus? No, that's a correlation. Okay. So first of all, it was a random sample of students. The word random implies like a survey, right? Random implies survey, which tells us it can't be a causation from that. We have to have a controlled experiment. And what else could have a negative connotation with riding to the school bus or having a cell phone? Maybe people that own cell phones they live close to the school. Maybe people that own cell phones have parents that drive them to school. Maybe people that don't own cell phones live out in the county and it's farther away because they have no cell service. I don't know. So you can come up with something there. All right. Causation, correlation. We're just saying yes or no this time. The student with the most correct answers on a test also had the highest grade. True. Causation. That is a causation. It's also a correlation. More answers you get right, better grade you get, but the most correct, highest grade. Going to cause it. Areas of the city with higher crime rates also have a higher homeless rate. That's just a correlation. That just is something that happens to occur. It is not the homeless that cause higher crime. Children whose parents smoke are more likely to exhibit delinquent behavior. Correlation. Okay, now we do know that smoking causes the probability of getting lung cancer to be higher, but we also do know that having parents who smoke doesn't mean you're going to be a delinquent. You can be a delinquent with the nicest parents in the world who never have smoked or done anything wrong. Calories burned during a workout increases when the workout intensifies. Causation. You're going to get more calories burned when you work out harder. Okay, it's been a long video. Sorry, guys. It's a lot of me. Me. Have a good day. Hey, you know what? Doing your homework causes your grades to be better and for you to have a better understanding of them. Causation. Yes, baby. See you later. We'll talk about it then.